Alright, we're going to go over how to do your rational and irrational numbers notes real quick to complete your BuzzMath activity. So remember, when we're changing 0.23, repeating, remember the bar is repeating to a fraction, we set our first equation equal to x. Since we have two decimal places repeating, we need to move our decimal twice over, which is like multiplying by 100. So this will be 23.232323. 100 minus x is 99x. And 23.2323 repeating minus 0.2323 repeating is just 23. The operation that's happening between 99 and x is multiplication, so we divide both sides by 99 because we have to use inverse operations, and we get 23 over 99, which you cannot simplify. Example 2, we're doing the same kind of steps. Again, we have x equals 0.666 repeating. We only have one number repeating this time, so we need to move it over once, which is like multiplying by 10. So this will be 6.6 repeating. Then we subtract our two equations. 10x minus x is 9x. 6.6 repeating minus 0.6 repeating is just 6. Divide both sides by 9, and we have x equals 6 over 9, which can simplify to 2 over 3. Next, we need to determine if the following are rational or irrational. Remember, rational can be a fraction and irrational can't be a fraction. Pi is the most common irrational number, so we're going to put an I. 2/3 is a fraction, so it's rational. Next, we have 3.456281. This is a terminating decimal. It ends. Since it ends, we can make it a fraction, so it's going to be rational. The cube root of 8 is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Therefore, the cube root of 8 is a perfect cube and is rational. Our first two examples, we're changing repeating decimals to fractions, so we know that this is rational. Next, we have 0.42136 ... Remember, the ... lets us know that it goes on forever. And we don't see a pattern here, so there's going to be no continued pattern. So this is going to be irrational. Negative 36 can be made a fraction by putting it over 1, so we're going to say it's rational. The square root of 39, if I go down my perfect squares chart, the square root of 39 is not on there, so that is irrational. The square root of 64 is a perfect square, because 8 times 8 is 64, so this is rational. On to the back. We're going to determine the the integers that square root of 68 is between, what perfect square is it between, and what is the closest. So the first thing we're going to do is we're going to draw our number line with the square root of 68 in the middle. We look at our perfect, this should not be square root of 68, or yes it is. 8 times 8 is 64, and 9 times 9 is 81. So it is between the integers of 8 and 9, and it's between the perfect squares of 64 and 81. Now we want to determine if the square root of 68 is closer to 64 or 81, so we're going to subtract. 68 minus 64 is 4. And square root of 81 minus square root of 68 is 13. So since we have a smaller distance here, it's going to be closer to 8. Last example. Again, we're going to draw our number line. Square root of 41 goes in the middle. The perfect square, 7 times 7 is 49, so that's our higher perfect square. And 6 times 6 is 36. Our whole number has to be 6. Remember, these two we subtract for our numerator, and these two we subtract for our denominator. 41 minus 36 and 49 minus 36. We get 5, and then 49 minus, or 49 minus 36 is 13. Now we have to make that a decimal. 5 goes in the house, 13 goes outside the house. We only have to round to the tenths place because we only have one decimal down on our number line. So 13 can't go into 5, so we add a 0. 13 goes into 50. 3 times. That gives us 39. With 11 left over, add a 0, bring it down. 13 goes into 110 8 times, and we can stop. So we have 6.38, and we want to round to the nearest tenths place, so we underline and look next door. Our 8 is higher than 5, which makes the 3 become a 4, so we have our answer as 6.4. Put a dot, square root of 41.